Today I am going to explain why Databricks job is taking too long to run. Here, if you see in the cell number 1, the code is I just imported some PySpark SQL import function as f and import random. I created a database. It is demo_opt. So with the PySpark code, I created 20 million rows with 3 columns: customer ID, amount, and region. All these 20 million rows, and with the data frame I am repartitioning to 400, and write mode is overwrite, and then created a table demo_opt dot transactions underscore slow. So now data is available in this table. So what I am doing here, I am just reading the data from the table, and then I am just apply group by customer ID and region. I am calculating the amount, total amount, and then transaction count, that also I am doing. So order by is the total amount. Just I am overwriting, the format is delta into the same table. But this table, when I executed, it took 7.8 seconds. But we need to see why it took 7.8 seconds. So for that, because we are in a serverless environment, so there won't be any Spark UI, but you can see in query history. So if you click on the query history, so you can see the metrics available for this query execution. So in this, this is a query, and total duration it took 7.78 seconds. So to see the details, just click on the query, and then you see that here you can see the ID, job ID, and the result, and total duration, start time, end time, and then bytes read, bytes written, and then rows read, rows written, 404 rows it written, and files read 400 files, and files written it is 1 files read, rows written is different, files written is different. And then you need to see the aggregated task time. Only for aggregation it took 19.11 seconds, and task time in the Photon is 95%. So rows written 0, rows read 20 million rows, and then bytes read this much of data it read, and then bytes written 5.90 KB, rows written 404. So if you see that where it is in the files and partitions section, this is the IO section. So you also need to focus on these parameters: read bytes and write bytes, and rows 404. So here files read is 400. This is a huge 400 files it is reading, means that much of memory it is asking the cloud environment to allocate the file. So that's why it took 7.8 seconds to complete entire thing. So you click on the query profile to more metrics, and if you click on this scan table, it took 17 seconds, 17.0 seconds. This is the time spent on to complete the 20 million rows. And if you see this, so only time spent is 17.07 seconds, and it uses delta, and it uses the Photon. By default it is activated Photon engine. And so adaptive query execution it is already applied, but here we need to understand that, but it read 400 files, that's why it took total completion time, it is showing that 7.8 seconds. So you need to focus on this area. 20 million rows is scanned, and then total files read 400. So what is the fix? Now we need to do it. See, AQE adaptive query execution, it is already enabled. So even though 20 million rows were there. And then so AQU, what it will do, it will avoid skewness, data skew. But what extra we can do, we can optimize to compact 400 small files into a handful of larger ones. So for that, what we need to do, we need to write a code. So like we need to write a code to using spark.sql and optimize the table and georder by the customer ID. So we are ordering the customer ID, we are optimizing the table. What happens, the files behind the scenes, they compacts and it reduces the number of files. So after I executed this step, and in the next step, if we run the same logic that we executed in cell number 2, here I am reading same from the table, and then I am applying the same group by, and then calculating total amount, and then transaction count, and then order by the total amount, and then I am just writing it. So this time it calculated with the optimized version, it took only 4.9 seconds. So what happens, we'll see here. Then view all in query history, go here in the query history. Here if you see here in this screen how it appears, this is the query and duration is 4.86 seconds. If you want to see more details, you need to click on the result. Here you see that total wall clock duration, this is the total duration is 4 seconds 855 milliseconds. It will give a different job ID, and then this is the query, and then start time, end time, and then bytes read. Here if you see that 148.81 MB. So whereas in the earlier case it was more MB. The rows read here 20 million rows and rows written 404 rows written, but it read only 2 files. In the previous case it was 400 files it read. So means when we did optimize, it compacted to 2 files. So the files read now reduced to 2 files. Files written, that is the output, it is written only 2 files. If you see details in the query profile and go to the same scanning operation here, and in the scan table, if you see here, the performance that time spent on only this operation is 1.27 seconds, and peak memory is 32 MB, output rows is 20 million rows. So you see here the earlier case files pruned 0, files read earlier case 400, now only 2 files. So all these 3 parameters would be same. So this is how we can avoid taking long to run of any Databricks job. This way you can apply the Databricks optimization techniques that I already showed in my previous video, that you can apply and you can improve your job performance. Thank you.